I'm Megan.
And I'm Delise.
And today we're going to show you the chemical traffic light. Now we are ready.
Pour 300 milliliters of distilled water into the flask. Make sure it's exactly 300 milliliters.
Place the measuring paper onto the scale and set the scale to 0.
Measure out 8 grams of potassium hydroxide.
Measure as close to 8 grams as possible.
Next, pour the potassium hydroxide into the flask of distilled water.
Shake gently to help dissolve.
Measure out 10 grams of glucose.
Pour the glucose into the solution of potassium hydroxide.
Shake until it is a homogeneous mixture.
So now you're going to take your second flask, then you're going to take a graduated cylinder and fill it to 25 milliliters of distilled water.
Pour the distilled water into the second flask.
Measure out approximately 0.25 grams of indigo carmine.
Pour the indigo carmine into the second flask and shake.
Pour the indigo carmine into the first flask.
As you can see, the indigo carmine has turned the solution dark green.
We took a time lapse over the course of 2 minutes. You can see that the solution turns from green to red to yellow.
By shaking the solution, the colors will revert back to green. You may be wondering what the chemistry is behind all of this.
Well, we're going to tell you. So the reaction that's happening in this experiment is called the redox reaction.
Redox is a short form for reduction oxidation.
Basically what reduction means is the gain of electrons, and oxidation means loss of electrons.
As you can see, the solution starts off as dark green.
So when the solution is left untouched, you can see that it turns red. What's happening here is the oxygen is losing electrons while the indigo carmine is gaining electrons. So this is the reduction portion of the reaction.
Although the reaction can be reversed.
So once the solution is yellow, we can then revert it back to green.
To revert it, we agitated the flask. So when it turns yellow to red and red to green, the solution is being oxidized.
The oxygen is now gaining back its electrons while the indigo carmine is losing them. So basically, the dark green is the most oxidized color.
And yellow is the most reduced color. In conclusion,
That is our project on the chemical traffic light.
to revert it, we use agitation. Spider!
Ew.
Ew, don't make it drop on you.
It's okay.
Ew, it's right there, kill it.
Where?
It's right there.
Where?
Right there. Kill it.
It's on my shoe now.
Okay. Ew, Megan, that's disgusting.